Today we're going to just review multiplying polynomials. How do you multiply polynomials? Polynomials are basically expressions with terms in them. So what are the different types of polynomials? Well, you could have a monomial, which basically means one term. So something like 3x squared, just one term. You could have a binomial. So bi meaning two. So I could have 2x plus 1 or a minus. Okay. You could have a trinomial. That's three terms. So we could do 5x squared plus 6x minus 2. And then pretty much after that, we start just calling them polynomial. So I had given you a handout in class, and you'll notice that two of these columns involve binomials being multiplied together. The last column involves a binomial being multiplied by a trinomial. Okay, we're going to treat these two a little bit differently, realizing that whenever we multiply polynomials, we always use distributive property. But for the time when we are just multiplying binomials, I am going to introduce you to FOIL, which is a method of multiplying binomials. It does not work on any other multiplication of any other type of polynomials. It only works for when you're multiplying two binomials. Otherwise, you just stick with straight up distributive property. Okay, so let's talk about FOIL. So FOIL is just an acronym, and it's used to help people remember how to multiply two binomials. Now, you'll hear, sometimes teachers will say, I don't like FOIL. And the reason that they don't like FOIL is because it confuses people when they're not working with two binomials. So again, if you're using trinomials, you're just using distributive property, okay? And FOIL is just a method of the distributive property, but it's a certain order. So FOIL basically stands for first, then outer, then inner, then last. Okay, so I'm going to take, I'm going to do two of these first in the first column with you. I'm going to do number 1 and number 6. Okay, so let's do both of those. So for number 1, now I'm not saying that distributive property will not work. You can double distribute these all you want. And I know that you all know how to do that. Okay, but what I'm asking you to do is kind of really pay attention to these two, the outer and the inner. Okay, what's going to end up happening is you're going to be given the product of these, and you're going to have to get back to these two binomials. And so if you know how to do FOIL, it's going to make it a lot easier for you. Okay, so first of all, the first is basically the first two that we normally distribute. So that equals x squared. Okay, the outer is actually this x, so the first term in the first binomial, and the last term in the last binomial. Okay, and so that basically gives us our positive 5x. Well, you're like, okay, first of all, nothing's changed so far. That's exactly right. Nothing's changed. Okay? The inner is the first or the last term in the first binomial, first term in the second binomial, and that's going to be 3x. And then the last are the last two terms in both binomials. And I simplify. Okay, so why am I making a big deal about this? Here's why. So I want you to look at this one more time. X plus 3 and x plus 5. It's important to understand where this number comes from. Okay, and this number comes from taking the outers and the inners. So the outers and the inners. So here, my inners are 3x and my outers are 5x. And together, they give me 8x. Okay, my first two terms give me my first term, right, this x squared, and my last two terms give me that last term. But it's really important to understand that those inners and outers are what give me my middle term. And that's why FOIL is valuable, because what we're going to end up doing is we're going to end up taking this product, okay, this trinomial, and factoring it out back into two binomials. So it's important that you're able to understand, okay, well, this number right here basically comes from the factors of 15, right? 3 and 5. And from the factors of x squared, x and x. So what we're going to end up doing is we're going to end up factoring these two things to come up with potential factors of this trinomial. Okay, I think I lied. I think I want to do number 12 instead. Let's do number 12. Okay. All right, so once again with FOIL, okay, I'm going to do my first terms, which gives me my 6a squared. Outer terms, which gives me negative 3ab. Inner terms gives me negative 16ab. And last terms gives me positive 8b squared. So combine this all and I get 6a squared minus 19ab and a positive 8b squared. So once again, just to show you the importance of those inners and outers, I'm going to rewrite this one more time. And I just want you to realize that your inners give you this negative 16ab, and our outers gave us a negative 3ab, which gave us our middle term, right? That negative 19ab. So if I was going to now take this and go back to this, the two binomials being multiplied, what I would need to do is I would need to figure out what are factors of 8 and what are factors of 6 that'll end up giving me that negative 19. And I promise I'll talk way more about it, but I really need you to just right now be familiar with inners and outers, give you that middle term. All right, and then let's just do one more of these. How about 16? All right, so now this time I can't really use FOIL. I'm just going to use the straightforward distributive method. Okay, there is no fancy term for this one. Again, FOIL only comes if you have two binomials being multiplied to form a trinomial. Because what we're going to do is kind of reverse FOIL it. We're going to be given a trinomial, and we'll go back to these two binomial factors. All right, so for this one, it's just straightforward. I'm going to take and distribute my first term to all three terms in the second polynomial. So I would end up with 4n cubed minus 28n squared minus 8n. And then I'm going to take the second term, and I'm going to also distribute that to each thing. So negative 5n squared, positive 35n, positive 10. And now I'm going to combine all my like terms. So I guess we need to identify what those are first. I don't see any other n cubes, so that's all by itself, so I'm going to keep that. I see an n squared here and an n squared there, and they're both negative, so I should have negative 33n squared. I see a negative 8n and a positive 35n. Those are like terms. So 27n, and then just one constant, plus 10. And that is my final answer. Okay, so I guess I should circle my answers here. There's 1,